Hooray. Good morning. Thank you for waking up so early to see our talk. We're going to talk about web security, like PHP stuff. And we're French. We're really happy to be there. It's really super great. And we are working in the same company, the 3 people here. It's called NBS. It's really a small one in France. And we are hosting a lot of different websites that are doing stuff like selling shoes or things like that. And we are hosting really awful lot of different PHP applications. And the problem that we're trying to solve is that some of our customers get pwned every day because they are running PHP stuff. So how can we get them to not get pwned on a daily basis?
Okay, so currently we already have some level OS hardening with PaxNGR security, for example. We also have a lot of custom IDS on the client web server to detect attacks, and we also use WAF that we wrote for Nginx that is called Naxé. Everything is great, but unfortunately it's not enough to patch or to protect every website with from all vulnerabilities. And also we cannot touch the customer PHP code, and we also don't really want to do it. And so, before we were talking about Snuffleupagus, a few stories about PHP. So PHP is a great language. Its syntax is based on C, Java, and Perl. And its goal is to allow anyone to write web pages quickly.
This one is a citation from Rasmus, the guy that originally created PHP, and as you can see, he is aware about some of the issues that the language holds, so I'm not going to paraphrase him. And so, yes, writing a real programmation language is a tough job and shouldn't be given to anyone. And when it comes to PHP, there's a lot of things about parsers as well, and that's why it can make sometimes our job difficult. I don't know if you try to use these things in PHP, but it's quite interesting. So now on to the thing. So how PHP address some kind of vulnerabilities? The thing that you know, it has this online documentation, and everybody can comment on the documentation. And for them, sometimes a way to address a vulnerability is just by adding a comment saying, "Don't use this to do that." But as I said, everybody can comment on the PHP documentation, and so people are just like somehow sharing some cool vulnerabilities all together and some vulnerable implementation of various features. And the thing that some of the vulnerability we find in the PHP documentation that was written by users as examples, you will find them in real life as well, and you will find them over and over and over and over again.
So what about hardening PHP itself? There was a great project called Thuocene by Stefan Esser. You might have heard about this guy. He's working on iPhone security now, I think. But we are in 2017, and Thuocene has some issues like useless feature, and it lacks some useful ones that we'd really like to have. And it's not really, you can really use it if you've got an awful lot of different websites. And you can't use it on PHP 7, it's the latest version. I think that PHP 5 won't be supported anymore by the end of the year, something like that. So yeah, you have to move to PHP 7, but you cannot harden it because suicide doesn't work. So what can you do? You can reinvent the wheel and write your own PHP extension. And it's called the Snuffleupagus because it's fun to pronounce it. For those who don't know about Snuffleupagus, it's a character from Sesame Street, and you can find it on Wikipedia. And it looks like this. It's an elephant like PHP. But why have we filled the slides with Babar? That's because the nice talk called Totally Spies from 2 years ago, it was about a malware called Babar. So we thought it might be fun to use Babar everywhere in the slides.
So the main feature of Snuffleupagus is to be able to do PHP level virtual patching. With PHP, you've got by default a configuration option called disable function that allows you to completely disable a function. So, for example, if I don't want my website to be able to call system, I can just put it in the configuration that I want to disable the system function. The major drawback of disable function is that it's global. You can either forbid totally system, or you have to. But if you need the system function in only one file of your website, you need to allow it globally. So, with Snuffleupagus, you can, like with the disable function in PHP, you can completely disable function call. And you can also allow a function call only in a specific file. So here we just wrote a rule that will allow the function system to be called only in a file that is called up.php, and then we say drop the function call for every other file. And you can also add some filters on the rule. So here we've got an example where we specify the hash of the file to be sure if an attacker is able to modify the up.php file, he won't be able to execute his code, because if he modifies the file, the hash won't be good anymore. About the syntax. So, as you can see, this is not a standard PHP configuration syntax. We had to design our own syntax because the PHP syntax is not nearly flexible enough for what we want to do. We've got quite a few filters to apply on function call. Everything is documented. We've got a lot of examples in the documentation, and the syntax was designed with a few goals in mind. We wanted to be able to patch every WordPress vulnerability, every vulnerability that was released by RIPS last year, and some high-profile vulnerability, or even our own 0 days, but we'll talk about that a bit later. You can also write some pretty complex rules. So, for example, here's the first one. You will drop the call to the function internal func only if internal func was called by the method1 method in the myClass class that is in the PHP thingy namespace. Also, in the configuration, order matters. So here we also allow the call to the admin cron thing function only if the call comes from localhost, and we disable the call for everyone else. You can also filter on the on variable content. So, for example, you can say disable the render tab call if you see that in underscore request, so all the variables that have been sent to PHP, if you see the tab parameter with a double quote in it. and you can also match on the argument position. So, for example, the first argument, if it doesn't match an alphabetic string, drop the call.
Sebastian just showed some examples. So now let's move on to trying to actually fix some vulnerabilities with it. So as we said, PHP, it has one great aspect that it's quite easy to use, and it's quite dangerous because it's too easy to use, and it offers some kind of features. So, for example, the system function, for those that don't know PHP, it allows you to execute an external program. The documentation actually warns you, says beware, don't give untrusted user input to this function, else bad things are going to happen. Hopefully, people are not listening at all to what he said, and we just see this kind of things happen pretty often. And overall, there were quite a lot of vulnerabilities related to this. The thing is that relying on the syntax that was shown previously, we can somehow prevent the exploitation of those vulnerabilities simply by denying some specific characters in the argument to the system call. In this specific case, by denying all the characters that can be used to inject shell commands, we're able to make the vulnerability unexploitable for the attacker. System is one example, and I think it's one of the most famous and classical PHP vulnerabilities. Some are less known and were popularized a bit later. For example, for mail, the documentation simply says that you can give additional parameter to the mail call, which is then passed to the MTA on the machine. It was mostly popularized by RIPs quite recently. And so people are just usually letting arbitrary user data get into this parameter, which in turn, depending on which mail client is installed on the machine, allows the attacker to get remote code execution by giving additional flags. How we can limit the impact is simply by putting some extra filters to this parameter in order to be sure that the user cannot supply optional flags that can lead to remote code execution. However, we know from experience that nobody is going to take time to write rules. So instead we look at how we can simply and purely kill some bug classes.
For example, when you're popping an XSS, most of the time you're about to steal the cookies, the session ones. And like Suyosin, you are encrypting the cookie server side with the IP address, a secret static key from the server, and an environment variable. Because originally Suyosin was using the IP address, but in 2017 people are roaming a lot, like you're using your mobile device, you are on 3G, and then you're back home on Wi-Fi, and then your cookie is invalid and you must log in again. It's painful. That's why we provide a way to use environment variable instead, like TLS session or thing like that. So even if you're roaming, you won't get disconnected. And since the cookie is encrypted with your user agent and a variable tied to the user, even if you manage to steal the cookie from the user, you cannot use it. And the administrator gets an alert in his log. So it's pretty handy in my opinion. It's completely transparent. Speaking about cookies, if the user is coming with HTTPS on your website, the cookie automatically gets the flag, the secure flag, saying that the cookie can only be transmitted over HTTPS. And if the cookie are encrypted, the flag HTTP only is set because it's encrypted, so there is no point in using it in JavaScript, since it will just be garbage.
So file upload, what the documentation is saying, pretty much nothing. For PHP, if someone can arbitrarily upload file to your web server, it's only you can only maybe leak sensitive information, not execute code or anything. But so what people are doing, taking user file and just putting them in the document root and let you execute them. I'm not sure if there is a single PHP application that allows the user to upload files that wasn't vulnerable to file upload at some point. And how we're killing it, this is a feature that we take heavy inspiration from COZIN. When a file is uploaded, you can specify a script to be called. The script will take in parameters the file, and then you can analyze it to allow or deny the upload. What we like to do is to use VLD. It's a PHP module that allows you to take a PHP file and disassemble it, and you will get all the PHP opcode of the file. So if the file contains valid PHP, you will get a lot of opcode, and you know you can drop the upload because the file most likely contains valid PHP. Unserialize. The documentation is warning to not pass untrusted user input in unserialize, or you can get code execution. But unfortunately, nobody cares about that. And people love to use a serialized PHP object instead of JSON or stuff like this to serialize data on the client side. Again, a lot of PHP applications vulnerable to this. And to kill it, we are abusing the PHP serialized format parser, because if you put anything that is not valid serialized data at the end of the PHP object, the parser will just discard it. So we calculate HMAC of the serialized object. We append it to the serialized string, and when unserialized is called, we just recompute the HMAC, validate it, and if it doesn't match, we just drop the call.
So once again, the documentation warned developers about the possible use and limits of RAND. And again, as it seems to be quite a trend, people are obviously ignoring this and using RAND for things like reset token, 2FA authentications, etc. And thus we are getting quite some public vulnerabilities, but most importantly, there's a lot of vulnerabilities in smaller applications that don't get any publicity, and where weak usage of RAND can be abused by attackers to bypass authentication or things like this. How we are killing it, it's simply and purely just replacing RAND by its more secure friend that is already present. So somehow just helping the hand of the PHP developer to do what the documentation says. Then the XML external entities. So for one, the documentation didn't say anything. Luckily, people wouldn't have read it anyway, so they keep giving user untrusted inputs to the engine. And then we are getting various XXC vulnerabilities. Once again, how we can simply kill these vulnerabilities by disabling the dangerous feature at the startup of the XML engine, and then looping the call to future occurrence in case the developer actually plan to do things the right way. So with both virtual patching and some family of vulnerabilities that are purely and simply killed, we can advance a bit further into securing the PHP application that we're hosting for our customers.
And that's the funny part of the talk. Because it's not a sales pitch, we're going to show you actually some demos. So yesterday, we were at the lobby and we had the idea of auditing some stuff to burn vulnerabilities, but then we get wasted, so we're going to burn some old ones. Are people familiar with this software like LibreNMS? Someone is using it in production? Good for you then. It's a monitoring software. It's a lot of PHP and provides fancy graph. So you've got a lot of metrology. It's really great. About disclosure, those are reliable ODAs, so please do not burn them. In the install.php file, there is an authentication bypass, like you can set anything in session by sending post data. You just have to emit a curl request, and congratulations, you're administrator on LibreNMS. And you can patch it this way by checking that in the post variable there is no fancy stuff, you just drop the call. There is also a remote code execution because using system, because why not? So a single curl request and that's it, you've got a shell. And you virtual patch it the usual way by blacklisting some character or whitelisting stuff into the system call. So yeah, our product is working. Speaking of cool stuff, we've got the Schmod hardening. Like if someone is trying to do a Schmod 777, you can just drop the call. You can also prevent execution from PHP files that are actually readable. So you can just make your website completely read-only. And if someone managed to upload a file, it will likely be readable, and so you can deny the execution. We've got also some really super ghetto SQLi hardening stuff. Like if you're trying to smuggle some comments into a SQL request, odds are that it might be an injection. And we're also collecting stuff, because if you've got a line like this, you can say, oh, by the way, I'd like you to drop every single request that is hitting this point if it matches this request. So you can get 3 ODays just by running your software. About performance impact, it's deployed on some pretty big websites, and we are using it for a customer. And so far we didn't notice any slowdown at all, like literally, because the slowdown depends on how many rules you have, and as long as you don't have 3 million rules, you shouldn't notice a single difference. We still got stuff to do, like fixing bugs and finding new bugs to fix them. And we still have bug classes to kill, like cross-site CSRF, sloppy comparison in PHP, because PHP try to be smart. Like if you are comparing 2 strings, PHP will try to cast them into integer before comparing them, because why not? It's pretty handy. And we have some plan to completely kill SQLi at some point. And then the release party, of course. And it's still not a pitch sale, so this is completely free software under LGPL. You can get it on GitHub, and I wrote a shitload of documentation about it, like how to write rules, the threat model, things like that. We've got also a lot of unit tests. I think the coverage is close to 100%, something like that. And if you've got question or suggestion, we are super friendly, so come drink with us. And that's what you get at the end. And we have 5 minutes. Something like that. Time for some fun. Since we're speaking about PHP, did you know that PHP is supporting emoji? Well, actually, it doesn't, but this code is valid because it doesn't recognize emojis like just using super large UTF-8 characters. And that's my favorite slide because PHP is using ZenVal internally. It's like a generic structure for its variable, and now it's moving to ZenString. And you've got a really awful lot of different macros to interact with them, and their name is always changing super slightly. So it's super great to develop in PHP and super great to debug your code when you have to deal with Z underscore something or ZSTRVal, ZVal, ZSTR. It's amazing. And we published it, I think 1 month ago or 2 weeks, I don't remember. And someone posted it on Reddit, and on the top you've got someone on /r/php, and at the bottom /r/netsec. So it's pretty fun because on the top people are bitching about it, and at the bottom people say that's a pretty good idea. The slide deck is full of code, so this is the last one. And we'd like to thank a lot of people, like the RIPS people that are writing a PHP scanner that is really working. Section Heinz that wrote Suicide, so we borrow a lot of their ideas. Arden PHP project wrote a lot of exploits that would like to kill. And WebSec for keeping our vulnerability alive. It's a challenge website. And we've got a lot of friends that tested the software, and a lot of people called us names for writing stuff and killing bugs. And we're on time. Thank you very much. If you have questions, we'll be happy to answer them.
Hey, thank you. So, questions? Over there, over there, over there.
Hi. Looks like a great tool to use, security-wise. So this is a module?
Yes, it's a module. You just have to slap it on your setup and it works.
So it's written in C?
Yes.
Yes. So if you disable a system call, for example, so the system function, would it be possible to re-enable this from PHP?
No, because we are hooking the system function in PHP.
So there's no way from PHP code to re-enable that?
No, you have to get some memory corruption.
Right. Okay. Thanks.
More questions? No? Okay, well, we'll have more time for coffee. Thanks, guys.